Hello, everyone. I'm Dave Rubenstein, editor-in-chief of SD Times, and I'd like to welcome you to another SD Times live program. This one is titled From Source to Container, Gaining Productivity with Open Source Paketo Buildpacks. With me today is Ram Iyengar. He's the chief evangelist at Cloud Foundry, and we'll be talking about how those build packs can detect the language your app is using, gather the required dependencies, and build it into an image. Ram, good to be with you today. How you doing?
Hey David, I'm doing fine.
Good.
Happy to be here and share what little I know of Buildpacks.
Well, I think it's more than a little, but anyway. Yeah, let's get right into that. It's a fascinating thing to me. As we've discussed in the past, I know build packs have been around for at least 10 to 15 years. But what I'm kind of curious to know is maybe you can just get into a little bit, how exactly do they work? How does it detect the language? I understand how it pulls in the dependencies, but then how does it create the image?
So there's something known as the Buildpack lifecycle that's fundamental to the way Buildpacks work. Let me quickly share a sort of architecture diagram as I go about this, so it becomes much clearer to those who are viewing this. So what you're seeing now is a visual representation of the Buildpacks lifecycle. It basically consists of a bunch of different steps or stages where the initial parts is where the Buildpack scripts actually detect the language and the framework. And then subsequently, it uses that information and some metadata, if it's given, to finally build and export the container image. So if you notice here, there's a step known as bin detect. So bin detect is really where that magic happens, which you were asking about, which is how does it know what the language or the framework is? So bin detect internally has a bunch of different ways where it compares the source code itself for known patterns. Now, one example is if you have a package.json file, it is more than likely a Node.js based app. If you have, let's say, a pom.xml file, it is most likely, no, it is a Java app, right? Or one of Java's very closely related families, things like that. So every language and every framework has their own way of organizing their source code and links to their dependencies and things like that. And so it's really about looking for these patterns and deciding, here's what a potential um, source code family is.
Mhm. Okay. Excellent. So I know one of the things that you talk about when you talk about developers using build packs is all about the developer experience. And I know that, obviously software development has become way more complicated, much more complex, many more moving parts, all kinds of things going on. So how does the use of build packs actually enhance the developer experience?
I think we've already hit upon like the big thing, which is, you just have to supply source code, not have to write and maintain things like Docker files and so on. And one of the examples that I love to use from time to time is Netlify. Netlify and the whole sort of JavaScript ecosystem, in my opinion, perfected the way developer experience should be. You just supply your source code, and from that point forward, there should be a platform or a tool that is capable of taking that source, building an immutable artifact out of it, deploying it, and keeping that in production for however long it takes. So Buildpacks aims to provide this exact experience irrespective of which language or family that you're using. So if you go back to the image that I showed a little while ago, the Buildpacks experience is about taking the source code, reading through, the source itself, some metadata, and doing this irrespective of what language or framework that you're supplying to it. So whether it's a Go app, whether it's an NPM based Node.js app, or if it's a PHP application, what have you, the process from the moment a developer finishes writing code to the container build, irrespective of where you build it, in production, in pre-production, for local development, doesn't matter. It should be a homogeneous step. Instead of, if your PHP, containerize it that way. If you're Node.js, then use these things in order to optimize your containers, etc. So it should be a best practices first method of developing a container image, irrespective of what language you're using. And that's really where build packs shine.
Mhm. Interesting. So I know that I'm sure there's a lot of automation involved in having these parts all kind of come together. So what is the important part to know about that kind of automation, when you're talking about the focus of build packs being on automation?
So what so the tricky part here is to find a balance. Now, oftentimes when we say, Buildpacks is capable of doing X, Y, and Z, or some other tool is capable of doing A, B, and C, usually people assume that it comes with certain opinionated paths, and I guess they're not entirely wrong in the case of Buildpacks. So Buildpacks offer a particular set of defaults, a very powerful set of defaults, might I add. Now, on the other hand, are meant as a specification. So Buildpacks themselves, the Cloud Native Buildpacks project, that's a part of the CNCF, is a spec, and it dictates how you should construct this tool called a build pack in order to take advantage of a simple build process. Now, part of the spec is to have SBOMs. Part of the spec is to have the best way to start containers and stop them and things like that, and commands for that, etc. Part of the build process is also getting dependencies and caching them and reusing this very powerful cache that can really bring down build times when you build them for a second time. So yes, there's a lot of automation, and build packs offer a sane default, but there's also a way to customize build packs to do exactly what you want and exactly how you want it done. And I think that starts from the fact that build packs can be written in many different ways. You could use a shell script, you could write it in Python, you could write some Rust based build packs. So it offers tremendous amount of flexibility as long as you stick to the spec and follow all of the different steps and things like that. There's no reason why you shouldn't write build packs that automate the build process for your specific requirement. And so yes, build packs come with a high degree of automation, but those can be opinionated at times. But build packs also open up this ability to automate in a certain manner. And so you can write your own build packs for doing stuff that are very specific to the build process that you want to see.
Mhm. Interesting. So I know these are cloud native build packs. So when people talk about cloud native, immediately they're thinking, okay, Kubernetes containers. But when build packs originated, were they specifically for containers, not for containers? Do you have to use containers to build this?
So, like all good technology, Buildpacks also has a very colorful history. I'm going to go back and throw a quick slide on the screen. Um, that will sort of explain a little bit about the history of Buildpacks. All right. So, to answer your question, when Buildpacks originally began, they did not mandate the need for containers. They basically just created an artifact out of whatever code that you supplied to them. So the first instance of use of Buildpacks was at Heroku. So if you ever remember the git push master Heroku command, which was total magic back in the day, it was all enabled by the use of Buildpacks. And at that point, so I'm going to call this circa 2012, okay, because that's the first time I saw what Heroku could do and what Heroku was capable of. And that's really when Buildpacks started to dominate the scene. And then about 4 or 5 years into that, the Buildpacks community had forked into two. So there was the original Heroku folks who continued to create Buildpacks and maintain them. There was no need for containers. And then there were the Pivotal folks who started Cloud Foundry. So I'm just going to add Cloud Foundry here for reference's sake. And so when Cloud Foundry started to use Buildpacks, they initially did not use containers either, but eventually they evolved into what were known as um, garden containers, and then Diego containers. So droplets were what containers were called inside of Cloud Foundry for a long time. And so in order to create a droplet, you made use of a build pack. And build packs were used both for containers in the Cloud Foundry world and for non-container based deployments in the Heroku world. Now, I'm going to draw a big sort of line here, which is this is the time when uh, Docker started and Kubernetes soon followed. So this is sort of our Docker's world. And this is when container orchestrator was sort of subdued, and Kubernetes emerged on top. And from this point onwards, it did not make a lot of sense to not do containers. So the whole world was sold on containers. The different communities around Buildpacks decided to then come together, and this is going to be 2018 or 19 when the Cloud Native Buildpacks project first emerged. And then they said, hey, let's converge around a standard for Buildpacks that make use of containers and that follow this world of Docker like uh, containers for deployment. Let's have these deployed to Kubernetes and things like that. And around this same time, the OCI standard emerged, so the Open Container Initiative standard. And so, Buildpacks followed OCI standards, and ever since for the past now 6 years and going, it's been OCI based containers for the Buildpacks community that can deploy to Kubernetes, that can work with Docker-based workflows and things like that.
Great. Okay, so looks like we're getting close to the end of our time, but I do want to ask you, what's new about these now? What's coming down the pike? What do you see going forward?
So, the trend in the past few years has been, can you do ARM64? Can you do eBPF and all of these things with Buildpacks? Is it built for observability? Is it built for telemetry? What have you? And then more recently, it is what's the AI story here? So I think the focus of the Buildpacks community is to bring in a lot of stability and bring in a lot of features that put it on par with any other container based build. And the community has been fantastic about it. Just the sheer number of adopters is something that we can be very proud of in terms of how much the community has come, or how long the community has come in being able to support workloads that power Buildpacks based use. And for future, it's about seeing what we can do in terms of securing Buildpacks better, supporting both ARM and x86 builds on Buildpacks, depending on where the image is built or what parameters are passed to it and things like that. And of course, there's a lot of AI based workloads that are looking at phenomenal results when using Buildpacks. So I think the future is to capitalize on those things and make sure that Buildpacks is a de facto standard, irrespective of what you're trying to build, whether it's AI based workloads or some other general purpose workloads, and make it work and functional across all of these different platforms.
Perfect. All right. Ram Iyengar, Chief Evangelist at Cloud Foundry. Thanks so much for being with us today. Really appreciate it.
Thanks, David. It was a pleasure.
Yep. And I'd like to thank our audience for tuning in as always. I appreciate that. So until next time, I'm Dave Rubenstein again, Editor-in-Chief of SD Times. So long for now.